Hello everybody and welcome back to another C++ programming exercise video, and in today's video we are going to be going over C++ programming exercise number 22. Now C++ programming exercise number 22 says a positive number m is called composite if m is equal to a times b, where a and b are positive integers such that a is not equal to 1 and b is not equal to 1. If m is composite, then m can be written as a product of prime numbers. Let m be an integer such that m is between 2 and 100 million. Modify the program in exercise 21 so that if m is not prime, the program outputs m as a product of prime numbers. Okay, so basically what it says is it wants us to add another feature into our program. And the easiest way to do that is to create a brand new function. We're going to name this function prime factorization. And now make sure that you are using the programming exercise that we went over in the last video, which is programming exercise number 21. Make sure you use that one specifically. Now you write prime factorization and then you write an int num, comma, int list, comma, int length, comma, int first prime fact index. Oh, and also make sure that that is in the right place. After you're done with that, then you can just copy and paste what you wrote up here. Copy and paste it and slap it right down here. Okay. So now what you want to do right here is the first thing that you want to do is you want to include bool done is equal to false. And then you want to write in int index is equal to first prime fact index. After doing that, you cout num is not a prime number. Now all this function does is it provides all of the prime multipliers that make up a composite number. It doesn't change much of the program, to be honest, but it does add that extra feature. So then we can cout num is equal, we write in num and then after that you write in cout list index, and then you write in num is equal to num divided by list index. After doing that, you write in while done is not true and index is less than length while num modulo list index is equal to 0 and num is greater than 0. Then you write in cout. And then you write in list index. There we go. And then you can write in num divided by list index. Oh, num is equal. After you write that in, you want to come down and write in after the while loop if num is equal to 0 or num is equal to 1, then done is equal to true. And then we can write in at the bottom index plus plus. And that is the end of this whole while loop. Oh, and I just noticed this. Let me change that to list. So let me give you a quick rundown of what is going on inside of this function. Oh wait, sorry, we're not actually done yet. But that is more or less just the entire thing. So then we can write in if num is greater than 1, then we write in cout num cout and out. And in this case, if num is greater than that 1, that means that num is currently a prime number. So we write this in right there. Okay? Alright, so let me give a quick rundown of how this works. So we start off with entering in the number that we're going to do our operations with, the list, and that list, is going to be the list of prime numbers, otherwise known as prime list, that we're going to be entering. And the length is just going to be the length of that list. And first prime fact index is going to be what we have up here. We're going to declare a variable that is going to be named prime factorial index. So then we have all of this. So the first thing that we do is we take in bool done is equal to false, because this whole function isn't done yet. We bring in index is equal to first prime fact index, and we'll have that variable for later. And now we write in cout num is not a prime number, and then we write in the factorization of this number. So now after that we cout list index, and now currently index is going to start at the first prime factorial index. So then this whole function executes. So then num is going to be equal to num divided by list index. And now keep in mind that the first prime factorial index is actually going to be calculated in another function. That function is going to be prime test. We're going to modify this so that we could make it work with this function right here. So now after writing this in, and we have this because first of all we know that the first prime number is going to be list with index first prime factorial index, and then After this, we enter the while loop, which is going to be while we aren't done, and index is less than length. Now, inside of this, we write in a nested while loop, which is num, while num modulo list index is equal to 0 and num is greater than 0, then that means that this num is greater than 0 just ensures that we won't have an infinite loop, because if you have 0 divided by any number, you get 0. And we also just don't want num to be 0. And we see out after we write in the first element, then we write in the asterisk, and then we print out another list index. And then from there, it keeps on repeating until this becomes not true, most likely, or this becomes not true. Then we go down, and if num is equal to 0 or num is equal to 1, then we are done. And we keep on doing this until this if statement executes, and then we'll exit this while loop right here. And then each repetition of this while loop index gets added by 1. So this basically does is what we do is we test for each and every single prime number that we have created in this list. It tests for all of them until num is equal to 0 or num is equal to 1. So that's basically how it works. And then once we have them all divided up into our correct groups, then we come here, and if num is greater than 1, then we multiply it by num. And then we see out end out. Okay, now let's move on to altering prime test to fit our needs. Okay, so what you can do is you can actually remove everything that's inside of these little inside of these if statements, except for the breaks, and then we just have to alter what's inside of these if statements and nothing else. So inside of this first if statement, instead what you want to have is you want to have prime num is equal to true. Oh wait, I forgot, we haven't actually changed what's up here. What's in the variable declarations. You want to have more inputs. So after writing in length, then you want to write in bool and prime num, comma, int and first prime fact index. And there we go. And we can also declare these two variables at the top. And there we go. So once you do that, then you can come back down and then you write semicolon right there. So this basically just means is right off the bat, if num is equal to one of the list elements, then we set prime num is equal to true and then exit from the loop. And in this case, this whole function would not be executed because it is not a prime number. It is a prime number. It is not, in fact, a composite number. But bottom here, at the bottom right here, we want to write in prime num is equal to false. And then we write in first prime factorial index is equal to I. We can then set prime num at the bottom right here is equal to true. So I'm just going to explain to you what this whole thing does. I've already explained this. So basically what happens right here is this is the if statement that tells you what if the number that you got is prime. I mean, if it is a composite number. So in this case, if the element of the list that we entered is less than the limit, which we have declared up here. I've already explained what this limit is. It's like basically the limit of how large the number that we're calculating is. The numbers that we're going to work with can be. So we have that right there. And if it is less than the limit, or less than or equal to the limit, and if you divide any of those prime numbers, if you divide the number by any of the prime numbers, and you get 0, then prime num is equal to false, and first prime fact index is equal to I. And in no other cases is prime num going to be equal to false. So we can just leave it like that. And now we can actually leave, we are now done with the entire function. Now we only have to move on to the main function. So we can come up here and you can take a look at what we have here. So right now we don't actually have that much here really. So what we're gonna do is this is gonna be in the beginning, but we're gonna have to declare 2 more variables. One of them is going to be called int prime fact index. The other one is going to be called bool is num prime, and that's going to be it. And then we could this is going to be it for all the variables that we need to declare. So then we can come down here and we write in while number is less than 2 and number is greater than 1,000,000. There we go. I think that's 1,000,000 right there. Then we enter cout enter an integer between 2 and 100 million. I think this is 100 million actually. Oh yeah, it is. And then we cin number, cout, and down. So this here is just a while loop to ensure that the user does not enter an integer that is outside of the limits of 2 and 100 million. So basically, if they enter a number that is less than 2 or greater than 100 million, then they will have to repeat this step. Okay, anyways, now let's go. We see prime test, and now we could just plug in is num prime, comma, prime fact index. Also just noticed that. Okay, there we go. And now we can declare if is num prime is equal to false. And then we write in prime factorization number, comma, prime list, comma, size, comma, prime fact index, else cout number is a prime number. Period. And done. Now that should be the end of all of our program. So let's run the program. There's obviously gonna have to be errors, of course. Let's try running this again. Hopefully everything works just fine. Oh yeah, it worked. Let's go. So enter an integer between 2 and 100 million. Let's try 824,560. 824,560 is not a prime number. 824,560 is equal to 2 times 2 times 2 times 2 times 5 times 11 times 937. Interesting. We could try even smaller numbers like 5. 5 is not a prime number. I mean, 5 is a prime number, sorry. And then we'll have stuff like 80. 2 times 2 times 2 times 5. Okay, so that's pretty good. I hope you all had a good time doing this C++ programming exercise along with me. You can see that this program works without a doubt. And I hope you all continue to have fun doing C++ program exercises like this with me. I'll see you guys in the next video, and bye.